As we advance in society, we couldn't exist without wastewater treatment plants. The goal of the ammonia probes is making sure that we completely nitrify to reduce that ammonia as much as possible. We limit our disinfection process of how much ammonia we have to add to the system, so it reduces our chemical demand. We have now been transitioning more to using nutrient-based control of our aeration blowers. So in order to predict the blower demand, we want to use ammonia probes to predict what an oxygen demand would be, in theory be able to ramp up the blowers when needed depending on ammonia demand rather than an arbitrary dissolved oxygen concentration in the aeration basin. The expense comes in with doing nutrient control is, in order to do that, you have to get a wet chemistry ammonia analyzer, and those analyzers are in the neighborhood of $30,000 to $40,000, where a probe you could potentially get in that $10,000 to $15,000 range. So it's a huge cost savings from a O&M perspective on not only the upfront capital, but the routine maintenance that is required to keep these things up and going, calibrated, and whatever miscellaneous consumables you may have in a wet chemistry analysis.
So there's a great benefit to us to have ammonia nitrogen or ammonia monitoring with the online ammonia analyzer. What it allows us to do is to determine the background level of ammonia, and that helps us to more accurately dose our sodium hypochlorite or our chlorine to maintain our target chloramine residual. By having the ammonia analyzer and being able to target exactly how much chlorine to add, not only does it make our process run better, but it efficiently allows us to use chlorine. Chlorine is the chemical we use the most of, and so it costs quite a bit. So we would like to be as accurate as possible in our use of it so that we can save on our operating costs. And the ammonia analyzer helps us to optimize our chlorine usage.
Best achievement of my career, if I have to be frank, is to see my former students to succeed and to become successful engineers in their own right. That's the most impressive part about this job. And we use a number of these analyzers, including the ones from HORIBA, of course, and we use them mostly to evaluate what are the contaminants in the water, how much we have removed from the oxygen demand, for the contaminant load in the water. And we can calculate also how much energy is required to treat certain contaminants, which is very important to maintain the economic and environmental sustainability of the process while removing the constituents that pollute the water.
All my research is about testing instrumentation in the field. Especially in my case, I'm working with ammonium sensors from HORIBA, so everything is related to the technology of the sensor and how they work and how they were built. I believe in my generation, all the different problems and issues about global warming and environmental issues were pointed out. And I think it's now the time to invest in this and understand to change things. And especially for water, here in California, the drought is really strong. So I believe it's really important to give a strong interest in this field for the future.